Good morning, my dear students. Today I am going to discuss the next unit, organic compounds containing nitrogen. So, organic nitrogen compounds. I am Dr.R.G, Professor of Chemistry, who is taking class for you. So, when you say organic nitrogen compounds, that means organic compound containing nitrogen coming under this category. So, what are the important compounds coming under this category? One is Nitro Alkanes, another is amines, and third is cyanides and isocyanides coming under this category. So let me concentrate. First, Nitro Alkanes in this class. As usual, Nitro Alkanes having the functional group NO2. So, as in the case of alcohol, it is also, we can say, primary, secondary and tertiary nitroalkanes. So, these alkanes, how to test the presence of nitro compounds? If it is a primary, secondary and tertiary, this we have already discussed under the alcohols. The differentiation of primary, secondary, tertiary alcohol also the same way we have to use. Anyhow, let me give the different tests here. One test, action of nitrous acid. Nitrous acid is not a stable compound which is not available in the laboratory. So whenever we require, simply we have to add sodium nitrate and then HCl or water. If you mix, the solution will contain nitrous acid, so that you can use for the reaction. So here, primary, secondary and tertiary nitroalkane behave differently when treated with nitrous acid followed by KOH. Please follow. So primary nitroalkane gives a red color, secondary gives blue color, tertiary no color. So let me explain the reaction, kindly follow. So I am taking nitroethane example. So I am treating nitrous acid. That means mixture of sodium nitrate and HCl when you add. So this, when it is reacting with nitroethane, kindly follow one logic is there. Most important, students must understand this one. Whenever nitroalkane, if it is primary, the alpha, that is the carbon where NO2 is attached, there is two hydrogen atom is there. So in that case, what will happen now? So I can write nitrous acid this way, double bond, the O double bond N OH. This is the structure of nitrous acid. So if it is CH2, what will happen now? This O will be eliminated along with this hydrogen. Kindly follow. So, this is the reaction taking place. Please follow. So, when there is CH2 group, this O will be removed. When there is only one H secondary, this OH will be removed. Please remember this logic. Easily you can write the product. Otherwise, you have to memorize all these structures. It is not necessary you have to memorize the structure. Kindly remember this logic. Primary 2H2, so this O will be removed. Secondary only 1H, OH will be removed. Tertiary there is no hydrogen, it will not react. Kindly follow. So, in the case of primary, and this O, after removing O, this NOH, this is called nitrolic acid. It is substituted into carbon double bond NOH. So when you treat it with potassium hydroxide, it is producing the substituted potassium substituted compound. Correspondingly, because hydrogen, this OH is substituted by K. So this will give red color. Please follow. So primary nitroalkanes will always give red color. So this is the test for primary nitrol. Coming for secondary, kindly follow. Coming for secondary. So in the case of secondary, I am taking now 2-nitropropane. I am taking. Secondary nitroalkane gives a blue color. Let me explain how it is giving blue color. As usual, this is having only one OH, so it will take this OH group. Kindly follow. So the remaining NO is attached here, intermediate. So what will happen when you treat with KOH? So it is giving blue color. Kindly follow water. So here I can give the guideline to remember. Kindly remember SB. State bank you remember. State secondary blue. Please remember this. Secondary blue means primary red, tertiary no color. So in the case of tertiary, kindly follow. So there is no hydrogen is present in the central carbon atom where NO2 is attached. So no reaction with nitrous acid followed by potassium hydroxide. So that way we can test primary, secondary and tertiary nitroalkanes. This is the most important reaction. Kindly follow. Test for nitroalkanes. Then as usual, what we are going to study under this classification, nomenclature, isomerism, preparation, properties and uses of nitroalkanes. Let me go for classification. Coming for classification, so it is classified into aliphatic aromatic. We know already how to differentiate aliphatic aromatic. So aliphatic again open chain, closed chain. Open chain again saturated, unsaturated. Aromatic, aryl and alkyl. So all example we have just simply changed the functional group. The remaining will be same. So coming for nomenclature of nitro compound. Common name we know already 3 types. One is we will call it as from source, from the nature of carbon chain and from the position of the functional group. Kindly follow. So, common name, nitromethane and nitroethane, a specific example. Kindly follow. And the 2 other things I have to mention here. What is the, based on chain, kindly follow CH3, CH2, okay, let me write NO2. Kindly follow. This is nitropropane. 1-nitropropane. It is, we will call it as that is a normal chain arrangement. So N-nitropropane. N-nitropropane. Please follow. N-nitropropane. Then again, the chain arrangement there is change now. So I can now write this is 2-nitro, IUPAC name 2-nitropropane. So I will give the name for this one is the correspondingly the second, that is the isonitro. Kindly follow. Isonitro correspondingly propane. Kindly follow. Or if you want to write again this way, kindly follow. If you take 4 carbon atom, you can easily understand that. It will be easy to understand now. Kindly follow now. If as usual, this is isobutyl. So this is actually iso. This is also iso we can call or secondary. Both are same. So this you take this example. Now in this case, so if you introduce a CS2 here, the correspondingly nitrobutane. Please follow. So you can take now comparing with this. This is normal, this is iso. This is based on the chain. Then let me take now based on the primary, secondary, tertiary. Just now I have given example. This is the example. Kindly follow. So this is now primary nitrobutane. What is secondary? CH3, CH3, CHNO, CH3. This is primary, this is secondary. What is tertiary? CH3, CH3, CH3 and this NO2. This is tertiary nitrobutane. So this is again common name based on the position of the functional group. Kindly keep remember this. The carbonyl carbon, it will not show this primary, secondary, tertiary. We cannot. Please follow. So these are the common name. Now let me come for IUPAC. I already discussed. So nitromethane, nitroethane, 2-nitropropane. These are the common example. Suppose if you want to, normally what they will give in the examinations. So suppose let me take this compound. This is tertiary butyl nitro alkane or nitro, that is corresponding to tertiary butyl nitro alkane. Kindly follow. So in this case, they will ask what is the IUPAC name for this structure. So as per the rule, what you have to take, you take the longest chain. So here N nitro, this is M methyl, alphabetically methyl comes first. So it is IUPAC name for 2-methyl 2-nitropropane. 2-methyl 2-nitropropane. This is the IUPAC name. So they will simply ask what is the IUPAC name for tertiary butyl nitro, the nitro compound, and even they will ask for this that is the nitro, the 2-nitro, 3-nitro, like that. They will ask the name. Give IUPAC name. They will ask common name, and they will give the common name. They will ask the IUPAC name. You should be very careful. Coming for isomerism, my dear students. What are the isomerisms? We have defined many times. Let me repeat again once again. Compounds having same molecular formula but different physical and chemical properties are called isomers, and the phenomenon exhibited by these isomers is called isomerism. A specific example we can give here. Simple example. Let me take now nitromethane and methyl nitrite. Kindly follow. So this is the two having the same molecular formula, CH3NO2. This is the molecular formula. So we can write this and also write this form way. Kindly follow. Now, what are the isomerism possible? What are the isomerism not possible? So chain isomerism possible, positional isomerism possible, functional group isomerism possible, optical isomerism possible. What are the isomerism not possible? Metamerism not possible, geometrical not possible. So students, you must understand why metamerism not possible. To form metamerism, the functional group should come in the center of the chain. So this is a monovalent, will not come center. And another geometrical applicable only for alkene-alkene derivative, that is not possible. All other isomerism possible for nitro compounds. Let me discuss one by one. First, chain isomerism. Kindly follow 1-nitrobutane, and then this is 1, 2, 3. So 2-methyl 1-nitropropane. Kindly follow. I simply say N-nitro, the N that is butyl nitrate, nitrite, and the tertiary butyl nitrite, common name. N-butyl nitrite and correspondingly tertiary butyl nitrite. Kindly follow. So, coming for positional isomerism. The positional isomerism, the number 1 here, we'll call it as 1-nitrobutane. Here it is changed to 2-nitrobutane. The position is changed. So this is the example of positional isomerism. Coming for functional group isomerism, I have already given. This is nitromethane. This is methyl nitrite. The functional group NO2, here ONO. So they are different. And finally, optical isomerism. All types of compound will show optical. Example, 2-nitrobutane. So I will write in the form of the RS configuration. I will write here. This is R2-nitrobutane. 1, 2, 3 clockwise. This is anti-clockwise. R and S. 2-nitrobutane. So R2-nitrobutane, S2-nitrobutane. I told you already regarding the optical isomerism. Optical means optical activity. But R and S will not give optical activity. It is the structural isomers predicted by Kahn-Ingold and Prelog. But what is you have to assume? R may be plus or minus if you measure experimentally by polarimeter. Suppose same way S may be plus or minus if you measure experimentally. Suppose if it is R may be plus or may be minus. If R is plus, S will be minus. If R is minus, S will be plus. That is the idea you have. So that's why instead of telling plus and minus, we are giving R and S as optical isomerism. Please remember. But it is important, you must know, it is based on optical activity we are measuring. But that the how to memorize this, it is very, very difficult. Kindly follow. Let me go for the another most important concept under this tautomerism. So many teachers taking in class, they are confusing with the students. This is also coming under the isomerism. No, this is not coming under isomerism. Isomerism means molecular formula should be same, but the compounds should be different. That is the different physical and chemical property. But tautomerism means not like that. If you take any compound, say for example nitromethane, I am taking, and if you put it in a suitable solvent, a particular percentage of the one form, that is nitro form, this kindly follow, this is nitro form, a particular percentage is converted into the acid nitro form, another form. Kindly follow. This is the tautomerism. Kindly follow. So, if you take in the solution, a particular percentage of nitro form will be there, a particular percentage of acid nitro form will be there. So, if you take the acid nitro form or nitro form, whatever you take, always it will give you a mixture of a particular quantity. Specifically, if you want, another example is, you can take acetone. This is called nitro acid tautomerism. This is called nitro acid tautomerism. Please follow. That means, please remember, here molecular formula same, but two different formula it should be there, separately behave. But here we are adding only one compound, but after dissolving in a solvent only, it is converted into another form of a particular percentage. This phenomena is different phenomena. It is called tautomerism. Please follow. So another example I will point out here. kindly take now in this case, let me take now acetone. Kindly follow. I will take acetone. So, kindly follow. So, this keto form, when you put in solvent, water say for example, it will converted in this form. Please follow double bond CH2. So please follow the arrow indicate this is more stable form, high percentage, this is the less as percentage. So this is called keto, this is form enol. So this isomerism is called keto-enol tautomerism. Keto-enol tautomerism. That means when we are dissolving acetone in a suitable solvent, say water, for example, immediately a particular quantity of acetone keto form will be converted into enol form. So major quantity only keto form. So this phenomenon is called tautomerism. Please remember. So why they are confusing that there are two functional groups, but it should be behave different way. But here it is a mixture. Kindly follow the difference. Let me come for the, as usual, general methods of preparation of nitroalkanes. So from alkyl halides I can prepare. Nitroalkanes are prepared by heating an alkyl halide with aqueous ethanolic silver nitrite. Kindly follow silver nitrite when you treat with general formula Rx. So X will be substituted by NO2. Kindly follow. So NO2 here it is minus. So RNO2 Ag. This is general. Specific example, ethyl chloride. When you treat with silver nitrate, corresponding silver chloride is getting precipitated. Correspondingly, then we are getting nitroethane. Easy method of preparations. Number two, another important, by vapor phase nitration of alkane. Vapor phase. For higher alkane like hexane and other alkanes can be nitrated using fuming nitric acid. However, the lower hydrocarbons can be nitrated only in the vapor phase at a high temperature. Kindly follow. 623 to 723 Kelvin. So this is actually examples of N-hexane undergo nitration to give nitrohexane. Kindly follow. This is the water. Suppose if we take methane, nitromethane, but temperature we have to maintain 623 to 723 Kelvin. So if it is higher, you can use simply fuming nitric acid. But if it is a lower member, you have to heat the vapor at high temperature. Please memorize, this is the second method. Okay. Coming for physical properties. Nitroalkanes are colorless, pleasant smelling liquid. Nitromethane is soluble in water, but higher members are sparingly soluble in water, but readily soluble in organic solvent. I told you nitromethane is soluble in water. That's why it is forming nitro and acid form. Kindly follow. So, first, let me come for the chemical properties. Under the chemical properties, first let me take action of sodium hydroxide. Kindly follow, the sodium hydroxide is a base. So how it can react, you can wonder. The interesting information is the hydrogen atom, alpha hydrogen atom present because of the NO2 group, withdrawing group, that is acidic in nature, that can be replaced by sodium. So alpha hydrogen atom of primary, secondary nitroalkanes are acidic and hence they dissolve in sodium hydroxide forming salt. So when you treat with sodium hydroxide, so H is replaced by OH, so that the Na, so we get nitro correspondingly, so nitro corresponding nitrous alkane. Kindly follow. nitromethane. Nitrogen substituted, water is formed. Kindly follow. If we take now a specific example, nitroethane, the same product it is formed. Kindly follow. Very, very interesting information. So first one action of sodium hydroxide, it forms corresponding acidic in nature, so that it forms the correspondingly substituted. Okay. Second reaction is halogenation. Primary, secondary and nitroalkanes, when treated with halogen in alkaline solution, are readily halogenated because of acidic hydrogen. So, when you treat with sodium hydroxide, we are getting this nitromethane. Trichloronitromethane, or common name chloropicrin, and 3HCl it is formed. Please remember, this is commonly asked chloropicrin. What is the IUPAC name? 1 trichloro, 1 nitromethane, chloropicrin. Suppose if I take nitroethane and instead of chlorine, if I use bromine, kindly follow. So what will happen now in this case? This CH2, there is one hydrogen is substituted, and further bromination, both hydrogen is substituted. Kindly follow. So we are getting here. So 1, 1 dibromo, 1 nitroethane. This is the product form. There, primary, all the 3 hydrogen substituted. Secondary, all the 2 hydrogen substituted. Kindly follow. This is also primary. This is ethane. Coming for action of nitrous acid. This we have already discussed under the taste. Anyhow, let me complete. Let me repeat. Primary, secondary and tertiary nitroalkanes behave differently when treated with nitrous acid, actually produced from sodium nitrate and HCl or water, then followed by potassium hydroxide, it will behave different way. A primary nitroalkane gives a red color. Kindly follow. This we have used as a test. So example, nitroethane, when I use nitrous acid, I told you, here also I will repeat. So whenever you take primary, there is CH2 group in the alpha carbon, so that O of a nitrous acid, so let me write easily, kindly follow. So this is the nitrous acid, kindly follow. This is the nitrous acid. When CH2 group H2, 2H2 is present, this O will be eliminated from nitrous acid, NOH will be attached. If it is only one hydrogen, this OH will be removed, NO will be attached. This you have to memorize. Tertiary, it will not react. So in the case of primary, as I have indicated, NO is substituted. So CH3, C double bond, NOH, NO2. When you add KOH, acidic OH substituted by K, it is giving a red color. So primary gives red color. Suppose if it is a secondary, what will happen? I will take secondary, 2-nitropropane. Secondary nitroalkane gives a blue color. Kindly follow. I told you to memorize. You remember SB. SB stands for State Bank. You can remember. It immediately come to your mind. State Bank means secondary blue. If secondary blue, primary red, tertiary colorless. You remember. So as I already informed you, only one hydrogen atom is there. So it will take OH to form water. Please follow. So NO will be substituted. And KOH will not react to insoluble. It is giving now color is blue color. Please follow. Whereas in the case of tertiary, please follow, there is no hydrogen in this carbon, so that nitrous acid as well as KOH, there is no reaction taking place, no characteristic color. Tertiary nitroalkane gives no color. So let me conclude now. Primary nitroalkane, when you treat with nitrous acid followed with potassium hydroxide, gives red color. Secondary gives blue color. Tertiary gives no color. Coming for the fourth property, hydrolysis. Kindly follow this acidic compound we are saying, it will undergo hydrolysis. When boiled with mineral acids, strong acid like HCl, primary nitroalkanes undergoes disproportionation reaction to form carboxylic acid and hydroxylamine. So let me explain with a simple example. I am taking nitromethane. I am treating with water in presence of HCl. So what is happening here? It is giving corresponding, there is only one carbon, so giving formic acid. And NO2, it is becoming in the form of NH2OH, hydroxylamine. So formic acid, hydroxylamine it is formed. Suppose if it is 2 carbon atom, corresponding acetic acid 2 carbon atom and hydroxylamine. Kindly memorize. This is the most important question asked often. What happens when boiled with mineral acid? Primary nitroalkane undergoes disproportionation reaction to produce as acid and hydroxylamine, depending upon the nature. Coming for reduction, another most important chemical property, acid reduction, commonly tin and HCl, iron HCl, hydrogen ranny nickel, iron under the presence of ranny nickel reduces nitro alkane is corresponding amine. That means NO2 group completely converted into amino group. This is the very, very interesting. If it is a strong acid medium, if you are a strong acid medium, it is a strong reducing agent, it is produce amino methane or methylamine. If it is a neutral medium, in this is tin and HCl is there, so neutral means zinc and ammonium chloride, it undergoes reduction to produce hydroxylamine, ethyl hydroxylamine. Please follow. This is the neutral medium. Kindly follow. Coming for the condensation reactions. Nitroalkane undergo condensation reaction with aldehyde and ketone in presence of alkali to give nitro alcohol. Because we know that hydrogen is acidic in nature, so it undergoes condensation. In presence of dilute sodium hydroxide, so what is happening? So let me write this structure, you can easily understand now. OH, kindly follow. So what will happen now? Plus CH2NO2 and H. So this, what will happen now? It will go in this way and this is added here. Kindly follow. So H will go to O, converting into alcohol, and the CH2NO2 go to the carbon. This is the product form. Kindly follow. Each way you can remember. Because of the acidic nature, it undergo condensation reaction. So what is the name of this compound? So it is actually according to the seniority table, OH should be named as a suffix, NO2 prefix. So numbering will be start from here 1, 2. So 2-nitroethanol. 2-nitroethanol is the compound produced in the case of primary condensation reaction. Now, again, another the condensation reaction with acetaldehyde. Formaldehyde we have seen. In the case of acetaldehyde, same way this is undergo, but the product will be different. This is 1-nitro-2-propanol. Secondary alcohol it is produced. Just see here, CH3, C double bond OH. Kindly follow. So we are adding CH2NO2 H. So here, this is adding here. So H is going here, CS2 coming here. So automatically this is a secondary. So what is the structure we can write? The CH3 COH. Kindly follow. H, CH2NO2. This is the actual compound. CH3, CHOH, CH2NO2. So now kindly follow. This is the parent hydrocarbon. Kindly follow. So this is number 2. 1, number 2, number 3. Please follow. So it is, I can name this 1 nitro propane 2-ol or 2-propanol is the correct answer. Correct IUPAC name. Suppose if you take a ketone, example acetone, the first member, the same thing will happen. So what way? The same reaction. CH3, C double bond O, CH3. Kindly follow. Here plus CH2NO2 and H here. It is going out in the form of here. So H will go here and CH2 will go here. So now what will happen now? It will become tertiary. So what will give name for this one? Kindly follow. The name of the compound is, I am going to write now CH3, COH, CH3, CH2NO. Because here I am writing linear, that will be very difficult to give IUPAC name. Now in this form, it is easy to give IUPAC. Just see here, structural formula. So as usual, number 1, number 2, number 3. So 1 nitro, 2 methyl, 2 propanol. 1 nitro, 2 methyl, 2 propanol. So always alcohol is secondary, but here it is a methyl group is additionally substituted in the case of acetone. Coming for uses of Nitro Alkane. They are used as a good solvents for a large number of compounds like vinyl polymers, cellulose esters, synthetic rubbers, oil, fats, waxes and dyes. It is also used in organic synthesis. Please follow. Whenever you want to introduce the NO2 group, we can use. The next, let me go for aromatic nitro compound. Specific example is nitrobenzene. Nitrobenzene. How nitrobenzene is prepared, laboratory as well as commercially. So you take benzene and add a mixture of nitric acid and sulfuric acid, heat strongly at the higher temperature for 1 hour. The final product will be nitrobenzene. Kindly follow. This is the simplest laboratory as well as the commercial method. Coming for physical properties, nitrobenzene is a pale yellow liquid. It is steam volatile and a toxic compound. It is heavier than water and almost insoluble, but readily soluble in other organic solvent. Now, coming for nitrobenzene chemical properties, as you know already, it is having the structure NO2 and aromatic ring. So we can classify the reaction into 2 ways. One is the reaction due to NO2 group and the reaction due to aromatic ring. We have to discuss. Any organic compound you have to discuss. This is the way method you have to follow. The first, let me concentrate reaction due to NO2 group. I will discuss later due to ring. First one, reduction, very, very important, please follow. And under the aliphatic, we have seen only 2. One is acid medium, another is neutral medium. Here we are going to see 4 types. Every year one question is asked from this. Please follow. So this is the most important, kindly memorize. So in acid medium, what is happening, kindly follow. Nitrobenzene undergo reduction in presence of tin and HCl or lithium aluminum hydride, strong reducing agent, converting into aniline, aminobenzene, and water is produced. So acid medium NH2, please memorize. Okay. Then, in neutral medium, what is happening? We know zinc and ammonium chloride. So this also reaction due to NO2 group is coming. In neutral medium, nitrobenzene undergo reduction to produce phenyl hydroxylamine. Please follow, this is hydroxylamine. When if it is H is substituted by CH3, we will call it as methyl hydroxylamine. This is aromatic ring phenyl hydroxylamine. So water. So neutral medium phenyl hydroxylamine. Coming for alkaline medium, please follow, very, very important. In alkaline medium, zinc and sodium hydroxide first undergo reduction to give the corresponding intermediate azoxybenzene, and further reduction gives azobenzene. Then reduction gives correspondingly hydrazobenzene. Please follow. This is azobenzene. This is hydrazobenzene. Hydrazo. Please follow. Normally, original compound is hydrazine. In the hydrogen, one H is substituted by benzene ring, another H is substituted benzene ring, which is called hydrazobenzene. Or simply we'll use diphenylhydrazine. Diphenylhydrazine also we can give. So this is hydrazobenzene, common name. Kindly follow. This is in basic medium. So third one. And fourth one, under electrolytic conditions. Reaction due to NO2 group under electrolytic conditions. When nitrobenzene is reduced electrically in presence of consulfuric acid, phenyl hydroxylamine is first produced, which rearranges to give para-aminophenol. Please follow. So, when you use electrolytic reduction, the final product is para-aminophenol. Please follow. Para-aminophenol. So, paracetamol is only derivative of this one. What is paracetamol? Kindly follow. This is the paracetamol. That is, so here NH, here COCH3. This is paracetamol. Paracetamol. What paracetamol in IUPAC you can say? This is N-acetyl aminophenol. Para-N-acetyl aminophenol is paracetamol. It is derived only from this para-aminophenol. Kindly follow. So let me compare now. Collectively compare. Primary, that is the kindly follow. That is in acid medium, nitrobenzene gives aniline. In neutral medium, phenyl hydroxylamine. In basic medium, diphenylhydrazine or hydrazobenzene. In electrolytic reduction gives para-aminophenol. Please memorize this. Now let me come for reaction due to benzene ring. Very, very important. So in the benzene ring, kindly follow the nitro group present there. Nitrobenzene, it is a very attracting group, strongly attractive, so meta-orienting group. So it will create positive charge in the benzene ring, so it will deactivate ring towards the electrophilic substitution. The reaction will be very, very less or no reaction. So nitro group is a meta-directing group. That's why all attracting groups are meta-directing groups. And hence, during electrophilic substitution reaction, meta-substituted products are formed. Let me explain that. How meta-products are formed. Kindly follow. So, whenever if you want to explain about the mechanism, you have to write the structure with the triple bond. Otherwise, simply put round there. Round actually bigger one. 2/3 of the size will be of the ring, according to IUPAC. So, NO2 attracting group. So, attracting electron from the ring. So, what will happen now? This electron move towards, here move towards, here move towards. So, what is happening? Only in meta, high electron density. In ortho, 2 ortho and para, it is, kindly follow, low electron density. So high electron density only in meta, any electrophile or E plus will attack only meta. So that's why it is called meta-orienting group. NO2 is called meta-orienting group. Let me take a specific example of nitration. So when you take nitrobenzene and if you just heat strongly again with nitric acid and sulfuric acid or even fumic nitric acid, you will get meta-dinitrobenzene or 1,3-dinitrobenzene. Meta-dinitrobenzene, 1,3-dinitrobenzene. Please follow. Coming for another one, chlorination. Again, NO2 group, meta-oriented group, so Cl will go to meta. So 3-chloronitrobenzene or meta-chloronitrobenzene. Please follow. 3-chloronitrobenzene. The next will go for sulfonation. Under again sulfonation, the reagent is consulfuric acid, always used. So it will provide a neutral nucleophile. Kindly follow, electrophile. Kindly follow. In all other reactions, actually, I have already discussed under the basic concept of chemistry, reaction mechanism, organic chemistry, I have discussed. There are 5 important reactions. One is Friedel-Graf alkylation, Friedel-Graf acylation, halogenation, nitration, and sulfonation. Even there is nitrosation, but it is rare. These 5 very, very important. Among these, the most important is nitration, halogenation, sulfonation is most important. Because in some cases, the aluminum chloride will form a Lewis acid, will react with the reagent. That's why these 3 is most important. Kindly follow. So what will happen now in this case? In all the 5 cases out of this, except this sulfonation, all other cases, neutral electrophile, the positively charged electrophile is attacking the reagent. Say for example, in the alkylation R plus, acylation RCO plus, halogenation X plus, nitration NO2 plus, and sulfonation SO3 neutral. It is acting as a attacking reagent. Please follow. Question can be also asked. So, in the case of nitrobenzene, when you treat with sulfuric acid, we are getting meta-nitrosulfuric acid. Please follow. We are giving priority for sulfuric acid group because if you look into the seniority table, after COH, SO3H will come. So this is IXI. Without COH any group, so this is the priority we have to give sulfonic acid. So we'll call it as benzene sulfonic acid. So it's by NO2, the meta portion NO2, so meta-nitro benzene sulfonic acid or 2-nitrobenzene sulfonic acid. Please follow. Coming for uses, it is used to prepare TNT, trinitrotoluene. Please follow. What is trinitrotoluene? Kindly follow. Normally, they will take the CH3 if you take toluene. So normally we are having NH2, that is TNT, trinitrotoluene. We are preparing that. So what is this is the trinitrotoluene. Kindly follow. So that is, this is trinitrotoluene, but actually is a TNT, trinitrobenzene actually this is. So what will happen now? If you take the toluene and if you allow to undergo nitration, this is producing 2, 3, 4, 6 trinitrotoluene, it is TNT. It is an explosive. It is used in making dyestuffs and paraceuticals. It is used for many organic compounds. Kindly follow. interesting information. Here one important information I want to go. The trinitrobenzene, suppose is in a highly explosive. So suppose if you want to prepare, you cannot prepare from nitrobenzene. If you take nitrobenzene, if you nitrate, you will get metadinitrobenzene. And if you want to nitrate further one more nitro group, that is, this is an explosive, the entire apparatus will explode and many scientists have died during the preparation. So what is the indirect method is from toluene we can prepare this compound. What we after preparing from toluene try TNT, trinitrotoluene, the toluene will be oxidized into acid group, then decarboxylation CO2 will go away producing this compound. Indirect method, please follow. So it is produced for many organic compounds. So I have come to the conclusion. My dear students, a student for the first time you are seeing my video channel Neat Chemistry by Dr.R.G in YouTube. Kindly click like and click subscribe button and share with your neighbors in YouTube. I have started this channel Neat Chemistry in YouTube in order to help poor students of India. Because I observed students are normally find difficulty in physics, chemistry, maths. So at least as a chemist, I want to help for chemistry students. That's why I started this channel. So in order to help for 8th, 9th and 10th students also, I added these chapters included in the CBSE as well as amateur books present. Added in the basic concept of first unit, I add all the chapter. Normally in the book there are only 16 pages, but I have taken nearly 16 to 17 lessons I have taken in this 17 hours class I have taken, just imagine. Because this is only to give the fundamental basic idea to understand. It's called basic concept of chemistry. Please follow. So coming for the other side, that is for students who are waiting for NEET common entrance examination for this academic year, that is studying +1, +2 and completed student, I have a good news for you. We are running a coaching center, Vetri Coaching Center in Pondicherry, near bus stand, for the last 20-21 years. And we have our own site, website, vetri.s. Please follow. And if you go, enter vetri.s and you go into the home page about us, if you see, you can see a lot of achievement we have created there. One of the most important achievement I want to convey, R. Srinivasa Raghavan in 2003 came All India first rank in JIPMER entrance examination. All India, nearly 4 to 5 lakh students were writing exam, he came first rank. This is the first achievement. In 2003 itself we have achieved this. And the other important achievement, every year we are sending 10 to 20 students are sending to JIPMER Medical College. 150 to 200 students are sending to other medical colleges through government quota by merit. And a few students are joining IIT and hundreds of students are joining other engineering colleges. This is our achievement. All the proof with the photograph, it is given in the home page, kindly verify. And the most important feature for you students who are going to attend for this academic NEET entrance, Vetri.test will be very useful to you to score minimum 650 to 700 marks minimum you will get if you go through fully, if you join Vetri.test. Kindly follow. It is a low cost, only 10,000 rupees we are charging, you have to pay. When you go for other online, they will collect more than 1 lakh. Now, what is the important features of Vetri.test? What way this is superior than other with coaching, online coaching? Let me explain. Number one, We have 200 video lessons. Number 2, 200 unit test. The 200 video lesson approximately is just 50 lesson in 50 in physics each subject. Let me take chemistry. There are 50 tests, just 50 video lesson. Let us assume now. Actually, we have 30 units, so it will be more number of lessons will be there. Kindly follow in the chemistry. So what will happen now? Each video lesson are taken by the professors with doctorate degree and 20 to 30 years of teaching experience in IIT coaching and medical coaching for the last 20 to 30 years. Not only that, they are also teaching still BSc, MSc, MPhil and PhD students. So they will give very clear idea, concept to understand the lesson. So another advantage, the video lesson, you can see the video as a YouTube. It's a classroom atmosphere it will create. You can see the notes, full of notes will be there. And if you want to take the notes, touch the video, it will stop. Take notes and then again touch, it will run. Like that. Or below there is even no, you can, with the help of that icon, you can even move the video anywhere you want, anything you want, you can see. Kindly follow. So, the very important information I want to give, all the chapters are taken up to the level of PhD level, so that students who are attending for IIT advanced test, the PhD level questions will be asked, so they can easily face the IIT advanced examinations if you join with your daughters. And also, kindly follow, we have 200 unit tests. What is the special feature from other online coaching? All the 200 unit tests or questions are taken from previous 20 years of IIT, AIMS, AFMC, the AIFPMT, MSET Andhra, Delhi, Karnataka, Kerala, Tamil Nadu, Pondicherry. Only these question papers of 20 years question papers are included in the 200 unit test. Each unit, kindly follow, have 2 tests. So for example, this is nitro compound. Under the nitro compounds, we have 2 tests, test 1 and test 2. Actually, this unit have 3 lessons. So we will have 2 tests. Each test will have 45 questions. So what we have to know, let me come for how to attend the unit test. So first we have taking the unit test of nitro compound. Go there and just touch the test, it will go inside and there is an attempt menu, click attempt, immediately a window will open. The window will give information. This unit contains 45 questions, duration 45 minutes. Each question carries 4 marks. The one of the option is correct. For correct answer 4 marks, wrong answer -1, subtracted. Are you ready? It will ask. So immediately what you have to do now, take a rough notebook and pen to do exercise problem, workout problems, and then click OK. If you click OK, immediately the window will open. Question number 1 you can see. Option A, option B, option C, option D you can see. And below that there is a clock is running. From 45 minutes, it will go reverse. And below that there is menu, 3 menus. And below here there is 1 to 45 number in yellow color it will be there. Please follow. This is unique feature of Etidatus. So in order to assess self-assessment, you can do yourself. So if you are reading question number 1, so you observe that A is the correct answer. Click A. Immediately what will happen now? See here, the number 1 question yellow color becoming green color. 2 becomes blue. All other question will be yellow. And you can simultaneously see that time also. So if you want to go there are three menus. Center is complete. You should touch only at the end of the completion of the test. Another is next. You can go for the next question. And this is the reverse, to go reverse. Kindly follow. So with the help of this, next you can give next go give answer. After finishing all the 45 questions, and suppose let's say this way, 20 minutes you have attended already. And you just see time, you can see, and how much time still remaining, and how many questions you have attended, that will be in green color. You can easily see the last number. Very easily you can assess. So according to that, you can adjust the time. This facility is not available in other online coaching. After completing press complete, immediately mark will be displayed. So let us assume your mark is displayed as 140 by 180. Why 180 total marks? 45 into 4, that is as per the NEET rule, NEET examinations. So 180. So, but you are getting only 140. That means you have lost 40 marks, you have lost already. So you want to know where you have done mistake, where you have done correctly. That facility we are providing, but this facility is not provided in any online coaching, other online coaching in India. This is again important feature of Vetri. So there is a menu called review. Next to the mark, there is a review. A window will open. In the window, question number 1, you can see option A, option B, option C, option D, you can see. And last, you can see correct answer also will be given as yellow color. Option in yellow color, correct answer will be given. Below that, there is video solution. Please follow. The interesting information, since you have attended A is the correct answer, it will be in blue color. Correct answer will be yellow color. Suppose you want to compare these two, they are same, you can assume your answer is correct. If they are different, your answer is wrong. So you can do self-assessment yourself. Immediately go to video solution. Touch video. Immediately, professor having PhD degree will take class like classroom. He will be standing in front of your board. On the board, you can see the question, option, everything will be there. He will give information. Read the question, read the option, and tell what topic it is asked and what under subtopic, definition, formula, the diagram, anything it related to the question, he will give information. And also he will explain all other, the option also he will discuss. So then finally we will come to it. Why this is correct, he will explain. For that, in minimum 5 to 15 minutes, he will take class. See, this video lesson, this just like our video lesson, it will be there. But if you go for other online coaching, they will give only correct solution will be there. If you touch solution, it will go to the correct answer. Option will be there, correct answer. Below that, one word or one line will be typed matter, that's all. A dull student or a very weak student cannot understand the difficult questions. But our case is different. So we are teaching really to the average, below average and poor students fully well theoretically like classroom we are teaching. That way we are superior with the other online coaching. Please follow. Now, I told you already, it's a very low cost. Now I want to give the one important information for students who are going to write NEET and an examination for this coming academic year. So to get 650 to 700 mark, what is the important steps you have to follow? First step, kindly follow steps. First step, you attend the order botany, zoology, chemistry and physics. Only this order you have to start attending questions. Only known question you attend first, 100% known. The second step, You go for again order botany, zoology, chemistry, physics, again theoretical with the difficult question you have omitted without answer. Think twice, thrice again, and if you mentally, if you are satisfied it is 80% worth, then put a click. Otherwise, leave the question, don't answer. And third step, go to the problem. Chemistry will be having 1/3 of the question will be problems, minimum 10 to 15 questions. When you go for physics, merely 50% will be the problems. Nearly 20 questions will be problems. So what you have to do now, if you want to attend the problems, first to find out at what unit it is asked, and what subtopic it is asked, and what is the correct formula you have to substitute. Substitute the correct formula, introduce the data given from this question, introduce properly by again SI unit, multiply or divide, do calculation and find out the correct answer. The correct answer you can compare with the option A, B, C, D in the questions. And if the answer you are arrived is, if it is present in any one of the option A, B, C, D, put a click, tick. If the option is not correct, your answer is not there in the option, then verify again your calculation. And if it is coming, click. If it is not coinciding, don't answer the problem. Leave it. So finally, you come for the completion. So this method, if you follow, the good student, more than average student, 100% you can follow 650 to 700. My dear students, if you join Vetty.X in +1 itself, if you attend 200 unit tests, I can give guarantee minimum 650 to 700 mark you can score. Okay. So how to pay 10,000 rupees and join Vetty.X? Pay 10,000 in the name of Sandhi, Director of Vetty Coaching Center, Indian Bank account number 712719471, IFC code IDIB 000P134, and any query or any information, contact my cell number and WhatsApp number 98941 So, thank you very much for your kind cooperation. I will see you again in my next topic. Bye-bye.